So, here is a small briefing on the chapter on evaluation. Hopefully, it will make your doubts clear. Whenever any question appears for model evaluation, you must write it is a process of using different evaluation matrices to understand the machine learning model's performance. It helps to find the best models that represent our data and how well the chosen model will work in the future. It makes AI model to get better with constructive feedback as we can make improvements and continue until we receive a desirable accuracy. The feedback loop is essential for building trustworthy and reliable AI system. This type of content is actually useful for multiple choice questions also. It helps you to understand strength, weaknesses and suitability for the task at hand. Now, when we talk about evaluation, there is a small special technique which we are following, that is train, test, split. It is appropriate. This train test split is appropriate when there is a huge data set available to us. And basically, it is a technique for evaluating the performance of machine learning algorithm. It can be used for any supervised learning algorithm. That means the data should be labeled. The procedure involved taking the data set and dividing it into two subset. The first subset is the training data set and second one is testing data set. Here you have to remember that generally the training data set is 70. Generally, the training data set is taken as 70% or 80% of the total data, while the testing data set is taken as 30% or 20% of the total data set. That means if you are taking 70% of the training data set, you will be having 30%, remaining 30% of the data set as a testing data, while on other hand, if you are taking 80% of the data as a training data set, which will be training the model, the testing will be done based on the remaining 20% left data, which we consider as a testing data set. Right? The training data set is used to make the model learn, and the input element of the test data are provided to the trained model, which is actually trained based on the training data set during the evaluation. That means training data set is used where the training data set is used in the modeling, while the testing data set is used in evaluation. Okay. Now, the model makes the prediction and the predicted values are compared to the expected values. The objective is to estimate the performance of machine learning model on the data. Generally, on the data which is not used to train the model. Okay. Now, it is strongly recommended that you should not use the same data which you actually use to build the model. It is not recommended to use the data we use to build the model to evaluate it. It is because whenever your model is being trained, it simply remembers the whole training data set. And therefore, whenever you are going to evaluate it, it is always predicting the correct answer in the form of correct label. Such technique, if you are using, will always give the correct outcomes, and this situation is referred as overfitting condition. Now let's start with evaluation matrix. There are various parameters based on which you are going to evaluate your model. Let's start with the very first term, that is accuracy. Whenever we are working with the accuracy, you need to refer that it is an evaluation metric that allow you to measure the total number of prediction a model gets right. That means the model is predicting correctly. Accuracy is directly proportional to performance of the model. The better is the model and it more accurate the predictions will be there. I hope the first content is clear. Now the second evaluation parameter is error. It is described as the action that is inaccurate or wrong. It is referred to the difference between the model's prediction and the actual outcome, and it qualifies how often the model is making mistakes. and that too is good. Why it is good? The moment we refer to the errors, we are actually modeling it and further tuning it to reduce the errors in future. So we are actually working for the amendments in the AI model so that the errors can be minimized, right? So the entire goal of this cycle is to minimize the error and maximize the accuracy. Next is the calculations based on the actual data or the evaluation error components. Now, the first question may come. There are various numericals which are numerical questions which are based on these formulas. So, in case you are getting the data on actual data, as well as you are already provided with the predicted value, if you are asked to find out the absolute error, so you need to just perform the calculation that you are going to subtract the predicted value from the actual value and you will get the answer. If the question appears that is asking you the error rate, in that condition, the absolute, whatever error you have got, the value from here will be taken and it will be divided with the actual value. Okay, that means the result of error will be used here. Okay. Now, when the question comes on accuracy, calculate the accuracy, but nothing else is given to you. You have just provided with the wrongly predicted values, or you can say you are provided with the error. In that condition, the accuracy is calculated by using the value which you have obtained as an answer here, error rate, and this answer will be subtracted from 1 and you will get the accuracy. This is the another way of one of the way of calculating accuracy, 1 minus error rate. Okay, and last is accuracy percentage. The answer which you are getting from here, the accuracy answer, will be multiplied with 100 and you will be getting the accuracy percentage. I hope these links are clear to you. Next is classification. Classification is a term which is referred to a problem where a specific type of class label is the result to be predicted from the given input of the data. Right? We are working on the specific type of label since the data is supervised based learning. Now, the popular or the contents, or you can say the evaluation parameters which are there in your syllabus for class 10th are confusion matrix, accuracy, precision, and recall. So, one by one, we are doing this. Confusion matrix, if the question related to confusion matrix come, then in that condition, what you will be writing? Confusion matrix is a handy presentation of the accuracy of model with two or more classes, and the table is presented with the actual value on y-axis and predicted value on x-axis. Right? The number of each cells will be representing the number of predictions made by the machine learning algorithm, and they are following under different categories. Now, first of all, let's have a reference of all the four types of categories. The first category is true positive. Second is true negative, which is given under green color, which is indicating that the model is working correctly, right? And in case the model is giving some errors, so it will be given under two categories. Either it will be false negative or it will be false positive. Now, what are these things? You need to understand it. Kya hai? Predicted values are given along the, as we have just now referred, predicted values are given along the x-axis. So this is x-axis. So we are giving predicted values along this and actual value along this y-axis. Okay. Predicted values and actual values are always referred in terms of 0 and 1. 0 means that the answer is false, 1 means the answer is true. Similarly, here, in case the actual answer is true and actual answer is false, is given over here. Okay, now how you are going to refer it? In case the model predicted that some event is going to happen, okay, predicted is yes, and actual in the testing data also it is found that yes, the prediction was the event actually happened. This type of condition is referred as TP, that is true positive. Okay, if the model predicted that the event will not take place and actual also the event didn't took place, such condition is referred as true negative. Okay. Next is, in case the model predicted that the something is not going to happen, but actually the value said the event actually took place. Okay. So in this condition, the condition will be referred as false negative. Last one, in case the model predicted that some event is going to take place for sure, and according to our data set, the event is not going to take place. This is the condition which is referred as false positive. I hope the things are clear. That means the first condition is TP here. The second condition is this is true negative. Here we are placing false negative, and here we are placing false positive. You need to learn it, cram these place values, because once this concept is clear to you, all the calculation based questions will be accurately performed. Okay. Now, how are you going to convert the accuracy into percentage? We have discussed earlier also. Here also, whatever accuracy value you are getting, multiply it by 100, you will be getting in percentage. Simple mathematics formula. In case you are getting the question where all these parameters and categories are provided to you, TP, TN, FN, FP, in that condition, if you are asked to calculate the accuracy, so the accuracy will be the sum of both the green options. That means where the model actually predicted the correct answers. So the sum of top one, that is TP and TN, divided by all the predictions which is given by the model, right? And whatever answer you are getting, if the question paper is asking you in percentage, multiply it by 100. Otherwise, you may give it. वैसे I'll recommend you to give the accuracy in percentage only. So always remember to multiply it by 100. ठीक है? तो answer will be given in the percentage as a result. ठीक है? Now, accuracy alone is suitable in the condition where you are having good balanced data. Balanced data means equal number of observations are there, and everything is rightly proportional and given. But this is actually very rare chance of there are very very rare chances of such situation. So if your data generally the practical approach hai, in that condition our data is generally unbalanced. So in that conditions you have to use the other parameters of the calculation and evaluation. The other parameters are precision, recall, or F1 score. Let's start with the precision first. Precision is working as a calculative, you can say a ratio, where total number of correctly classified positives are actually referred, and they are divided by total number of positive predictions. That is correct positive prediction divided by the total positive prediction. Right? All positives. Matlab, you will be giving TP in the numerator divided by TP plus FP. Right? It is dealing with unbalanced data set where, and generally we are performing this calculation where false positive is actually holding importance, and we need to work on some methods to reduce the FP cases. Second parameter is recall. It is a measure of a model which is correctly identifying true positives, right? True positive is okay, but it is dividing by, in the denominator you will be taking total actual positive values. That means TP and FN. TP and F1. How to recall it? These are the actual positive values. If you remember, prediction actual values were, both of them were positives. Okay? So it is TP plus FN in the denominator. Recall is hopefully clear to you. Again, unbalanced data set, but यहाँ पर we are actually dealing with the false negative cases where they have to be reduced by trying to make some amendments in the model. Now, there may be a situation where you cannot decide individually ki what is holding importance. Is it only the recall or the precision? So in that condition we combine both precision and recall into a single measure, and where calculation is based on both of them, generally used in those cases where we are not able to decide whether FP is important or FN is important. So here we are giving the formula in this manner. You will be calculating F1 score by multiplying 2 with the product of precision and recall and divided by the sum of precision and recall. This is how you are going to calculate F1 score. Whenever you are calculating F1 score, remember precision and recall will never be should never be calculated in percentage. Otherwise, you will be having very long calculations. Again, during the exam, if you feel that the calculations are taking time, so you may leave it in the fraction lowest term also, right? But be very, very clear, show all the steps of your calculations on the same page. Even if you are doing rough work should be done on the same page. It's good that you perform all the calculation wherever you are attempting this question only. Now, another and probably the last topic of this chapter, this is something new which they have added this year. Expectations are there that maybe something from here should come. Now, while evaluating AI model, the ethical concerns, some ethical concerns should be kept in mind. There are three major ethical concerns. Remember it with their header's name: bias, transparency, and accountability. You have to remember every component from here. Biases, it is ensuring that the evaluation matrix does not result into any kind of favorism on a particular preferences on a particular set of data set, right? Second is transparency, honest explanation how the chosen evaluation matrix will work and produce a result without keeping anything hidden, right? Any type of information must not be kept hidden. Next is accountability. That means we are taking the responsibility of the choice of the matters we are taking and the methodology of the evaluation. In case any user faces a disadvantage or problem because of the methodology, the accountability will be there with the person. Basically, it is act of taking responsibility. This was the major component in the evaluation chapter. Hopefully, all your problems are now sorted. Still, if you have doubt, you all can always message me. Keep revising, get good marks. Good luck.